Now let's create a door panel, and it will also be a nested family. I will activate the File New Family command. Let's select the Metric Generic Model template. We don't need a wall as a base. It is already present in the parent family, so we choose a template without any host. First, let's set the category. We will indicate that our door panel belongs to the Doors category. And click OK. This nested family, unlike the profile, will be manually installed in the parent. We'll need to specify how to position its instances. The reference planes will help us to do this. Binding an instance of a nested family with the parent is carried out by using the reference planes. Moreover, for this operation, it is always worth choosing planes with the Defines Origin checkbox set. We already have such planes. This one will serve to bind an instance of the nested family in the direction of the opening width, and this one in the direction of the opening depth. We have to decide in advance which planes in the parent family we will attach to those of the nested one. We will align this plane to exactly the same one in the parent, since there it sets the opening center, and this is convenient for positioning the door panel. And as for this plane, a similar one in the parent is located in the wall center, and this position will not be suitable for placing the panel, since the wall center depends on its thickness, and we cannot predict its exact position in all possible situations. It is much more convenient to position the panel with a reference to the wall edge, or, for example, to the plane that defines the real depth. The door panel will have dimensions, width, height, and thickness, and we will need to tie-snap these dimensions to the opening of the parent family somehow. There are two options for doing this. The first one, form a grid of reference planes in the nested family and set the parameters similar to the parent, that is, create for example the width parameter and the reference planes that define it. Naturally, the door panel has a smaller width than the opening. Therefore, reference planes setting the indent from the total opening width by the gap and the door frame width are also required. The same has to be done in other directions, in terms of the height and depth of the opening. The second option, determining the dimensions of the door panel through formulas. We understand that the door panel width is equal to the total opening width minus 2 gaps and minus 2 width of the frame. We can use this formula. Let's do it this way, and then we will only need planes defining the door panel width. Let's build them and set overall dimensions. We also snap to the center plane. Let's assign the parameter to the size. Let's call it door panel width. In the nested families, if they are not a family with the profile category, it is often more convenient to make instance parameters, since then we will have to bind them with the parent family parameters, and it is easier to do this through the Properties panel than through the Type Properties window. For the direction along the opening depth, we will choose another options for binding to the parent family. We will not use formulas, but we will create planes for each parameter of the parent family. Thus, we will consider both options. If this plane corresponds to the one of the revealed depth in the parent family. Then, next, we will need a plane defining the gap. And then that's the one defining the frame thickness. Set the door panel precisely in the middle of the frame, and this plane will set the center of its thickness. Now let's set the dimensions. Let's place this plane at the center of two adjacent ones. Here we will assign the parameter gap. Again, even though a similar parameter is a type 1 in the parent family, it is more convenient to make it an instance in a nested one. The same goes for the frame thickness. All planes other than those used for position of the nested family instance in the parent should be set to not a reference value for its reference parameter. Thus, all these planes will not interfere with the alignment of the nested family instances inside of the parent. We can only cling to two main planes. Let's build the geometry of the door panel. To do this, create an extrusion element. Its contour must be rectangular. The panel edge's width can be aligned to the overall reference planes. And set a link between them and sketch lines through the locks. As for the panel thickness size, there are no suitable planes here. We will snap to the central one. To do this, set the dimensions. The size for snapping to the center and the overall size, to which we assign the parameter. I will call it door panel thickness. This will also be an instance parameter. Let's finish building the extrusion and move on to the elevation view. We will indicate the size to determine the door panel height. At the bottom, it is better to snap to a reference plane rather than to a level. The reference plane is highlighted with a dashed line. Let's assign the parameter door panel height. And we will align the top face of the extrusion along the reference plane. Next, let's create a material parameter for the door panel. To do this, select the extrusion element and find its material parameter. Assign the family parameter to it, which we will have to create. I will call it door panel material. I will open a 3D view and change the parameter values to test the working of the family. There are no errors occurred. Assign a subcategory to the extrusion. Many categories have a standard list of subcategories. We can see this list for the doors in the subcategory value drop-down menu. I will select the panel value. Subcategories are needed in order to be able to set different graphic parameters for different elements within the same family. Graphics settings in Revit are set according to object categories. And if there were no subcategories, then all geometry within our door family would have the same lines thickness, colors, and lines type. Very often, you need a different behavior. When, for example, the door panel shows lines that are slightly thinner than the door frame, and these can be solved through subcategories. Graphic settings for subcategories can be assigned through the Manage tab, Object Styles window. Standard subcategories cannot be deleted or renamed. At the same time, the user can create his own subcategories through the New button. The standard subcategories are also present within the project files, and there are also graphic settings assigned to them. When we load a family into a project, for the subcategories, we use exactly those settings that are specified in the project. So, there is no point in changing them here. It's another case if you create a new subcategory. It will not be present in the project files. It will appear there when the family is loaded, and its graphic settings will also be transferred from the family. So, it makes sense to immediately set the parameters in the Object Styles window for the new subcategories. I won't change anything. Press the Cancel button. Next, let's save our family. "100" is a family code. The codes can be arbitrarily selected. Within our company, a system of codes is adapted for different family categories. For example, a door has a code of 100. This is not a strict rule, but if you work with such a system, you can always understand, simply by the name of the file, which category the family belongs to. Also, codes allow you to structure families by grouping in alphabetical lists. That is, all doors will go in a row, all windows will go in a row. Some other families will also go together in such lists. This is a convenient way to organize your Revit family library. I will press the Save button.